First question. Difference between ADF pipelines. And Synapse pipelines. Come on, expecting answer from. Except Ceci. Remaining people, please tell me answer. Question is difference between ADF pipelines and Synapse pipelines. Of course, in the Synapse pipeline, finally ADF only. Chandrasekhar, Satish, Sirisha, Chendu.
Good morning.
I am not saying good morning, man. Please answer me, man. Please answer my question.
Can you repeat it again once, sir? I adjusted.
Already check the screen. In the screen, I typed the question. Difference between ADF pipelines and Synapse pipelines.
In ADF, we follow the ETL type of format, sir.
No, I am asking only pipeline.
You are asking about
Pipeline means ETL only, pipeline.
Yes. Okay.
Synapse is having Synapse pipeline. In the Synapse, you have integrate option. That integrate option is what? That is about pipeline only.
Yes. Okay.
That is the question. Ceci.
Sir, we can run this SSIS packages here, but I think in Synapse we cannot run SSIS packages.
In Synapse also you have that option, SSIS.
Okay.
In Synapse also you have that option. Only one thing, sir. Yesterday class we have seen.
Some Spark.
Spark tool notebooks you can run.
Yeah.
But in ADF, remember, Databricks jobs you can run. Here you have option notebook. In Synapse pipeline also you have option notebook as activity. But here in ADF pipeline, Databricks Synapse only, Databricks Spark only you can run. Okay. But
and
here,
Power Query is also not there.
Power Query is available in both, sir.
Okay.
Power Query is the latest feature. This is available in both. Okay. Here only Spark pool jobs. Got it. Databricks cluster is somewhat effective. Of course, maybe like especially, sir, year to year both are competitive. Microsoft has something in the mind. In future, maybe in future, not immediate future, maybe in long future, they will implement completely with the Spark pool only. But for now, they completely depend upon. So they depend upon Databricks. Okay. So in future days, in long future days, Microsoft will develop similar to the Databricks, very large clusters for the Spark, and then completely the Spark pool they will be using. Okay.
What is the main difference, sir, running in Databricks and
like
Spark?
in my tested, I tested with like 5 GB data, sir. 5 GB data. Actually, the test was is a CSV file. I tested with both Databricks and Synapse Pool. Both are Spark clusters only. Here the like a configuration what I have taken is the configuration 3 node and 8 core with 16 GB RAM. I have tested. Here also same configuration I have taken. Because whenever you are comparing two clusters, the capacity of infrastructure should be same, sir. So here 3 node, here also 3 node I have kept. 8 core for each node, 8 core and 16 GB RAM. Here also I have taken the same thing. When I tested with the 5 GB data load, okay, it has taken 7.2 minutes to convert. Here load activity means to convert that CSV file to data frame, Spark data frame. Here I have taken around 7.x minutes. Here it has taken 4.x minutes. Of course, in this first initial game, Spark pool win the race. After that, I applied aggregation, sir. Okay, whenever I applied the aggregation, here it has taken 3.2 seconds, not minutes, sir. Here it has taken 6x. I don't remember exact count, 6x seconds. And after that, the complex operation generally, when you give the databases, mostly industries to test with the sort operation. Here, with the 3 node cluster on 5 GB data, the sort took around 2.x minutes. It has taken 4.x minutes. That means there is something inside the Databricks cluster, especially in its architecture. Okay, how they are organizing the clusters, how they are manipulating the processes, that depends on internal architecture of them. Data loading 7.x, of course 4.x, it doesn't matter. Once the data is loaded, next onwards the processes are required. While loading, Synapse winner was better, but while processing, especially once data came into the warehouse, next onwards the analytics related operations, right? For those analytics of all analytics operations and complex data operations, Databricks is giving you faster results. But coding style is for you, for the developer, there is no difference. In so Spark pool, same code you have to write. In Databricks, same code you have to write. Okay. But one thing, this is very costly. The Synapse pool is cheap. Suppose daily, my organization requirement daily to process 1 terabyte data. Suppose the Spark core is charging, the Databricks is charging, suppose like 1,000 rupees. This 1,000 rupees process is going to take 10 minutes time. Think that. Here the charge is something like 500 rupees. That to here, if the processing time is 15 minutes, then which is best? You have to decide it. 5 minutes is not a big deal. Suppose if I feel 5 minutes extra time is not a big deal, definitely I go for Synapse pool. Got it. Suppose 5 minutes might be very big time for some other organizations. At the time, even though the charge is high, they may go for Databricks on that way. Especially Databricks is very good for machine learning based applications. Because machine learning applications are very complex. Algorithms are very complex. To run such kind of complex algorithms or to iterative algorithms, Databricks has their own library for that. And also Databricks has additional libraries for TensorFlow and NLP and PyTorch. All these things are used for machine learning, deep learning, and NLP, and also reinforcement learning. Especially the application is very complex, the machine learning or artificial intelligence based applications. The Databricks has good track of record. Okay, because they have internal architecture is very efficient, the cluster architecture, and also one more thing, libraries are already available. Got it. But one thing here, you can overcome this problem with additional service here, Synapse Spark Pool, integration with Azure ML service. Same kind of facility if I need in the Synapse, the Spark Pool integration with Azure ML service, you can achieve the same. But Databricks, why Databricks is costly means, this question is just to remember in the answer. One, Azure process time charges. Additionally, what you have to pay is you have to pay DBFS. Still, if you want to use Delta Lake, the Delta Lake feature for Delta Lake features also, you have to additional charges. Got it. That's why when compared with the Synapse Spark Pool, Databricks Spark is some costly. Cost is suppose neglectable. If the cost comparison is neglectable, you can strike directly. You can use this one. If there is a huge difference in the cost, then they will decide. Okay, let's go this only with the Databricks or so Synapse. On that way, they will decide. Got it? Yeah. And one more point, important point. So where you will write your SQL scripts are in Spark?
Notebooks.
Not notebooks, SQL script. I mean TSQL script. So this thing you go to the data warehouse pool, that means SQL pool.
SQL, yeah.
Okay, under SQL pool, we have develop option. Under develop, select SQL script and give the script. But important note, currently SQL scripts cannot be placed under pipelines. Placed as activities in pipeline.
In any place or just in ADF?
In ADF and also in Synapse pipeline.
Okay.
And the same time, notebooks can be placed as part of pipeline. That means Synapse pipelines. Same notebooks you want to use, you have to write Databricks jobs in ADF. So for this, Microsoft has other product. Remember this, if any interviewer asks this question, to say the answer. Synapse private link is there. This is one service. Synapse private link. The service name itself, Synapse private link. If you have Synapse private link, then you can place SQL scripts. In Synapse pipelines. Maybe in future, Microsoft may offer this feature in basic Synapse. Okay. So when compared with last year, Microsoft has added a lot of features. Sir. Very soon, like within 1 year, this will become very rich data platform. Definitely. But at the same time, Databricks will also be not calm. It also will be keep developing the new features. In this way, always there will be a war between Databricks and other cloud platforms, especially for data engineering. Databricks is targeting only data-related products only, sir. But Microsoft is targeting a lot of other products, not only data engineering, other products also. Okay. So don't be fan of anyone. Okay. So don't be stick to I'm fan to Synapse Spark or Databricks Spark, not like that. Whatever the client, your client has asked to write, just use it. Spark code is the same, but in Databricks you are finally writing Spark. In Synapse Spark also you will be writing Spark only. The Spark is same. Okay, only backend cluster will be changing. Execution, there might be difference in the execution time. There might be difference in charges. That's it. That is client decision. Okay. Okay, sir. So this is just for information. I am giving this information. Now, a few more operations we will see in the Spark. By today, I will stop this Synapse session. How to perform multi-grouping operations. By Spark. Just please check it. I have data. Same, our previous file I am taking. The first field is ID, second field is name, next field is salary, gender and department number. In this way, I have many number of fields. I think that is a big volume of data. The last record. Like this. So example of multi-grouping query in a SQL. Select a department number, comma, gender. Sum of salary from your table. Group by department number and gender. What kind of output? If you submit this query, what kind of output you are expecting? Department 11. Under that, males are there. Only 11 for males. The total salary is suppose let's say 9 lakhs. Again within the 11, again females are there. The total salary is 5 lakhs. Again 12 males and 12 females. In this way, if there are 100 departments and 2 sex groups, 100 into 2, 200 rows you will be getting. Okay. So this kind of output you are expecting. Same thing, this can be possible by SQL. Suppose you tried with SQL tool. Think that the processing time it has taken like on multi terabytes of data, the processing time by the Spark tool is 5 hours. But now I am expecting this not in 5 hours. This should be done in 5 minutes or 10 minutes like that. That means I want to reduce this hours time into the minutes. At the time, you have to come to the Spark. Got it. So generally, sir, within less than 5 terabyte of volume, the Spark tool gives good faster results. More than 5 terabytes, that is very tough for the Spark tool. Okay. So at that, sorry, SQL tool. So in that moment, command do the same operation in Spark. So how to achieve that we will see in Spark. So remember this data shape. This is our data shape. Come on, Sasi, go ahead. What is our first step? Data is ready. Already think that this is in our data lake.
We
First
need
step.
to read the data.
So how to first we need to create RDD, right?
Yeah.
Data is equal to sc dot text file and do the path. abfss colon your container name slash your storage account name. Sorry, here at the rate storage account name dot dfs dot windows.core.net. Something, the path already have seen. Maybe some word I might be missed. .net. And after that, give the file name. Suppose the file name is emp.txt. Now this is RDD. Now how many, please answer me, how many partitions here? How many partitions? Sir, what is the file system type, sir? We are using this
Hadoop
protocol.
file system.
What is the file system type? Hadoop file system. Think that
Depends on the number of blocks in the.
if the file is having 100 blocks, 100 partitions will be created. 100 partitions will be created. Okay. Now step 1 is ready. Step 2. Split the line into words. Words equal to the input is the previous RDD. RDD dot map of lambda x. X is each line. X dot splitting based on comma. Okay. So this split operation will be done with 100 partitions parallel. Got it. In SQL pool, what is the max limit of partitions? I mean, distributions.
60 distributions.
60, that means this much of data to be adjusted into 60 distributions only, right? That means in the Spark pool you have, SQL pool you have limitation. You cannot go beyond 60 for one job. You cannot go more than 60 parallel processes for one job. That is the limitation. Suppose your file is too much bigger, it has 1000 blocks, you can go for 1000 partitions. Got it. And one more option here, please observe. Still your cluster is very big. I said 2. What is the meaning? I have 1000 blocks. Each block is divided into 2 partitions. That means how many partitions I will get in the RDD? Even though I have 1000 blocks, 2000 partitions I will get. You got my point?
ఉంది ఏమే
Sir, please mute.
కాదు ఒకటి
Vikram.
బ్లాక్ చేసిన ఇండియన్ బ్యాంక్ మళ్ళీ హెచ్డిఎఫ్సి లో మైనస్
Mr. Vikram. Yes, sir. Please come back. Sir, please try to understand this point. Did you understand about this one? I said file path, comma 2. That 2 is for number of partitions. Not total file is divided into 2 partitions. Each block is divided into 2 partitions. I have 1000 blocks. 1000 by 1000 into 2, 2000 partitions. A small calculation. $2,000 partitions divided by 8 cores. What is the result, sir? 250. That means if I have 250 nodes in my Spark cluster, in my Spark cluster, if I have 250 nodes, if each node is having 8 cores, each node has 8 cores, these 2000 partitions will be processed at a time by 250 nodes. One node has 8 cores. Under one node, 8 parallel process will happen. 8 partitions will be parallelly processed. Got it? Suppose for an estimated time to process one partition, 1 minute time. To process one partition, 1 minute time is required. Assume that. If I have 250 nodes, this much of biggest file which has 1000 blocks will be processed in how much time, sir? What is your answer for this? It's a general question. Client is ready to invest for 250 nodes. Your file has 1000 blocks. That too, we divided that into 2 partitions, each block into 2 partitions, totally 2000 partitions.
It will take 1 minute.
Just 1 minute plus time. Let's say an easy example, say let's make it as 2 minutes time. In just 2 minutes, your work will be done. Why that extra time?
The block is divided into 2000 partitions. 1:2 ratio.
No.
It
Forget
needs
about
to
storage.
agree, get the results from different nodes and combine it.
Different partitions will be processed by different cores, right? That means from each core, one separate result is produced, right?
Okay.
Hello, sir, please interact with me. From each core, for each partition, separate result will be produced, right? Again, processed results to be collected by some other nodes and final summary to be done. For that, extra minutes time is required. Maybe in just 2 minutes, your work will be completed. So that's why this is the power of the Spark. Why your data engineering platforms are involving notebooks into your ADF means this is the reason. Notebook means that is Spark process. Maybe Spark pool or maybe Databricks. Got it? So this kind of facility for very large files, very large files, Synapse SQL pool will not work out. Got it? But if you do, one more point, if you do straight away in ADF, how to trigger your Spark jobs? Without involving notebook,
Data flows.
data flows. If I use data flows, what is the problem? Same job, same biggest job. If I run with the data flow, my time might be 30 minutes.
Okay.
What is the reason? Because data flow is again converted as Spark.
Nodes will be decreased.
We can't customize the
You
nodes.
cannot customize how
Customize
many
the nodes, yes.
partitions to be there. You cannot customize that. All of you understand?
Yes, sir.
For such kind of customizations in special cases, we have to, even though data flows is supporting for structured data, in some special cases, we need to come to this one. Got it? Suppose this result, this is job 1. This is job 1. Job 1 is daily triggered by 9:30. Why 9:30 means job 1 input will be ready by 9:29. Input will be ready by 9:29. So that the job it is triggered by 9:30. But by immediately 9:40, job 2 should be executed. 9:40 job 2 should be executed. But it is taking half an hour time, more than half an hour time. At the time, the job 2 will be delayed or not. If job 2 has a dependency of input on the job 1. Okay, in some special cases, speed is highly demanded, especially for big data processes. At that time, you have to customize your work by this way. Understood? Okay, come to this one. What will be the data shape? In a high level is a list. Each element is a line previously. Now the line is converted into the list again. ID, name, salary, gender, and department. Whenever you split, each element is a string now. Again, second element, third element, fourth element, fifth element. Every element is a list now. But to perform my above aggregation based on department number, gender, and salary, I want to perform grouping aggregation. I don't want ID, I don't want name, I want only these 3 fields. We need to separate. That means we have to create key value pairs. The step 3, key value pairs. But one problem, pair should be in format of tuple. Tuple has only two things, key value. Key should be single, value should be single. That means only one field you can give as key, only one field you can give as value. But here I am expecting the department number and sex as key. Department as a primary key, that is a prime grouping key. Gender as secondary grouping key. But the rule is here. What is the rule? Key should be single. Value should be single. How can I manage this? Is observe this technique. I'm going to construct a pair. All of you, please high concentrate. Pair equal to input is words. Words dot map. Lambda x. Pair should be key and value. Key comma value. Right? In the place of key, I am giving a tuple. This tuple, the first department number, in the second gender array. In the place of value, I am giving salary. But how to give this department number? Department number is in last. How to get that? X of -1. That means last first. And in the place of gender, I want this value. How to get that? X of -2, last second. Now observe here. This is key. In the place of key, a single object I have given, a tuple object I have given. The tuple has two things. All of you understood this technique?
Yes, sir.
Value is salary. Salary is in third position. But I am converting that into integer. In the place of salary, I am giving x of 2, which is third one. Okay. In this way, how to convert. Now, what is the output of it? A list, a tuple, 11 comma m, and total salary. That salary is 40,000. Think that example says, so let's say 50,000. This is the first element. Again, second element. He is from 11, department female. Is a tuple of here one bracket. This is for the second element. Suppose her salary is 90,000. Again, third employee is a 12, but he is male. 89,000, like this. In this way, how many elements you have, how many records you have, that many key value pairs will be constructed. Okay. Now, step 4. Grouping aggregation. Grouping aggregation. Already key is there, but key is not single. Key is a combination of department and gender. Remaining results as usual. Let's say summary equal to pair dot group by key. Sorry, not group by key, reduced by key. Lambda x comma y colon x plus y. That's it. If you collect the results, summary dot collect, you will get output like this. the list of 11 comma male, the total salary 9 lakhs. This is as first topic. Next, 11 female and total salary. Same thing for 12. 12 male, total salary. 12 female, total salary. After that, convert this into string and then finally write into your text file. How to write into the text file? The results summary dot save as text file and give the path. But path should be folder, sir. Path of folder. Folder or container. Do this. All of you understood the technique, especially step 3 technique, how to create pair if you want to perform multiple grouping. Okay. Next is the final step. So first you tell me, sir. We have done 4 steps. The 5th step is writing results into output directory, which is your data lake file. So when compared with the previous process, where difference has come, especially in the 3rd step. Generally, key should be single to satisfy that a single object, a tuple of department number comma gender, we have given as a key in the place of value salary as usual. If it is understood, I will go to the next step. Already have seen execution process, sir. Just to save the bill again, I am not launching the cluster. For now, are you clear or not for this task? Shall I proceed to the next?
Yes, sir.
Yes, sir.
Okay. Now I am changing the task. Grouping by single column. But I need multiple aggregations. Grouping by single column and I need multiple aggregations on that. So to do this, so a simple example SQL statement I am doing. Select a department number, comma, sum of salary, count of salary, average of salary, maximum of salary, minimum of salary. From your table, grouping based on department number. So in this example, grouping by single column, but aggregations at a time, I need multiple aggregations. In such case, remember a small note for you. Dot reduce by key. Does not support multiple aggregations. That means only single aggregation. So how to solve this problem? If it is SQL pull, directly you can submit this query. But I observed I have 60 partitions distributions limit, but my data volume is bigger. I don't want to do it from SQL pool. That's why I wanted to write my own Spark code for this. But previous aggregations are done by reduce by key. Now I don't want to use that because of its limitation. It supports only grouping by single column. That means single aggregation. So for this, the solution group by key. That's it. How to do that? And what happens once you applied group by key? What will happen? Please check. As usual, I am repeating all the steps. Step 1, read data into RDD. Data equal to sc.text file and give the file path. The path already have seen that. Directly I am giving file. Next I am dividing that into the words. Data dot map of lambda x dot split. Splitting based on count. Next I need to construct a pair. Department number as key, salary as value. The pair equals to what you call words dot map lambda x. Department is last one, x of minus 1. That is as key. Salary, that is third one, x of 2. But salary I want to convert into integer. Integer or float, your wish. One more bracket for match. Pair is ready. So what are the values here in the output? First employee 11, salary 50,000. Next employee 12, let's say assume salary 80,000. Next employee again 12, 90,000. 11, 1 lakh. Last employee 11, 2 lakhs. Think that these are the 5 elements you have in the data. This kind of key value pair is constructed. Now I am going to apply the group by. Let's say object name, RDD name is GRP. GRP is equal to input is a pair. Pair dot group by a key. Group by key, that's it. No need to pass anything. Here key is always first one is key. Based on this, the grouping will happen. Got it? Now output is like this. You will get only 2 pairs. 11. There is a special collection object in the Spark, that is compact buffer. Compact buffer of, in the 11, all of you please check the output, sir. In the 11, how many elements are there? How many employees are there?
3.
3. All these the 3 people's salary will be formed as a compact buffer. First employee salary, second employee salary, third employee salary. This is one tuple. And second tuple for 12. The compact buffer of, there are only 2 employees in the 12. The first employee 80,000, next employee 90,000. Done. But if it is compact buffer, you cannot directly apply aggregations. That's why I am going to transform this into GRP list. GRP list is equal to pair dot, sorry, your input is GRP. GRP dot map of lambda x column. Sir, x is what, sir? This entire tuple is x. This entire tuple is x, each element. I have only 2 elements. In this, what I need, I want from this This entire thing is X. From that, I want the first department number as it is. How to take the department number X of 0? How to take the second one? X of 1. But this X of 1, which is second one, that is a compact buffer. I am converting that into list object. Now my tuple is ready. Now the output of your GRP list is like this. 11 comma a list of 50K, 100K, that means 1 lakh, 200K. Is first element, second element. At 12, in the place of value, instead of compact buffer, I will get 80K, sorry, 80K as first element, 90K as second element. Now the data is purely converted into Python objects. This is a Spark exclusive object, Spark exclusive data type. That data type you are converting into list. Now data is ready. Now I'm going to perform my summary aggregation. Summary is equal to grp list dot here I am applying here in this place I want 11 as 11, but in this place I want sum, count, average, max, minimum, everything. That's why straight away map I am applying lambda x colon. What is first one, sir? X is this entire thing. All of you look at this. X means this entire tuple. I want first one, which is department number as it is. X of 0. As a second element, I want sum of this one. Sum of X of 1. Next, I want to count len of X of 1. Next, I want the average. But there is no direct average function in the Python. That's why sum of X of 1 divided by len of X of 1. This is the next element. Next, I want maximum, max of X of 1. Next, minimum of X of 1. Okay. Now this bracket for this entire tuple expression, and finally I am closing the map function. Now if you collect the results from summary dot collect, the flow will be executed. Now the result will be a list of a tuple of 11 comma, suppose total salary, some estimated value I am giving, total salary is like 9 lakhs. Next count is suppose something like a 10. The average salary is 90K. The max salary is 89. The minimum salary is 30. On that way I will get. The same thing will happen for fold. After that, you want to write these results, apply the save as text file. Summary dot save as text file and give the path of output for it. Please scan the process what we have done. Step 1, as usual, data reading into RDD. Step 2, each line is split into the words. After that, you have taken key value pairs. Key value pairs you have taken. After that, instead of applying reduce by key, group by key apply. Why you applied group by key? The reason reduced by key supports only single aggregation. Reduced by key supports only single aggregation. That's why you applied group by key. And after that, but group by key is producing compact buffer. That compact buffer is converted into list. After that, for that list, you applied different aggregation. Department number, you are keeping same. On the remaining things, you applied sum, length, average, and then max, and then minimum. After that, you are writing the results into your output folder. Sir, the tomorrow biggest challenge is here. Sir, please, you are going to speak something. Any questions still now?
Yes. So as I said, the reduce function is applicable on only one key,
One.
right? What?
Yes. Yes. Only single aggregation. That's it.
Yes. What if in case of any need of handling that with multiple keys?
So in the same example, in the place of here, go to the pair. What is the key you have given? Department number, right?
Yeah.
In this place, involve the previous step. Give the tuple of department number, comma, gender. Understood? That means
So
your,
if I pass multiple keys at the pair level,
yes.
then that would support for the reduce as well.
No. If the reduce means only single aggregation. This is a single grouping.
Okay.
This is grouping key. Suppose you need a result like this. I am changing the query. Select department number, commas, gender, comma, sum of salary, comma, max of salary from EMP. Group by department number, comma, gender. Sorry, please
Okay.
mute, sir. Voice is coming echo. Now, how many grouping columns? How many grouping columns? Multiple.
2.
How many aggregations? Multiple. Your previous task was single grouping with multiple aggregations. Now, multi-grouping with multiple aggregations. Got it. So if I want to do this, what is the process? Very quick review. Please observe all of you. Data is equal to sc.txt file and give the file path. Your file is emp.txt. Next, split them into the words. Data dot map of lambda x colon x dot split. Splitting based on the comma. Next, you need pair. Pair is equal to words dot map lambda x. Here I need key and value. Observe here the game is starting. The value is salary. In the place of value, I am giving x of 2. That is third one. That way I will convert this into number int of x of 2. But in the place of key, I give tuple of department number, comma, gender. In the place of department number, I am giving x of 1, x of minus 1, which is last one. In the place of gender, I am giving x of minus 2. Understood? Now, still system point of view, the key is single only. A single object you have given as key, a tuple object you have given as key. Got it? But I want to perform multiple aggregations. That's why ZRP equal to pair dot group by. Got it? Now the output of this one is like this. The first element 11 comma m as key, think that there are only 2 persons in that. Is a compact buffer of 10,000, 20,000. Like this. Again, under 11 males, 11 females, think that there are again 2 persons. $20,000 and 30,000. Same thing for 12 male, 12 female, like that. Understood till now? To more maturize, convert this into Python shapes. I'm taking like a grp list equal to grp.map of lambda x colon. I need a tuple. Here x is this entire line, the tuple of this entire thing. So keep one bracket here. This entire thing is a tuple. First I need this one. To get that x of 1, x of 0. Next I will get, I have to get this one. For that, x of 1. This x of 1 is a compact buffer. I am converting that into list. Done. Okay. Now we can apply our summary. Summary is equal to grp list by dot map of lambda x colon. First I need this. For that I am giving x of 0. Next, the list of this compact buffer is already available in second. For that I am applying sum of x of 1. Next aggregation I need max of x of 1. Now it's red. One more bracket for that map function. Now save it. Summary dot save as text file and give the path of your output folder. Then your work is completed. Just simply submit this job. Later, if you want, keep this notebook into your ADF activity. That means your Synapse pipeline activity, and schedule it and run it. Sir, understood, Chandrasekhar? The last task is about multi-grouping with multiple aggregations. Clear?
Yes.
So this is one situation, even though data is structured, why you should use Spark coding. I repeat my question. Data is structured. Why to use Spark notebook? Even data flows existed. Answer please. For this question only you answer it.
To perform custom distributions.
Yes. To perform custom number of partitions. To provide more parallelism. Okay. Again, I repeat the question. Data is structured. Why not SQL queue? Why to go for Spark queue? Please answer.
Reduce the execution time.
Just
Limited partitions.
yes, limited number of distributions. That is right answer. SQL pool has Limitation of distributions. Okay, what is that count?
Distribution.
60 distributions per 1 table. That's why you cannot go beyond 60. Got it. So this is simply about the Spark. Okay, more Spark videos I will provide you. Hmm? So this weekend only I will start working on that. Okay, for now, sir, like I'm stopping this Synapse session. All 8:30 batch students, please attend tomorrow. Tomorrow 7:30 for ADF session, and 7:30 students and 9:30 batch students. Don't forget about our Saturday program. So Saturday, if necessary, we will sit on Sunday also.
Okay.
Okay, sir, all of you, let's meet. Did you get yesterday recording? Hello?
I don't think so.
No, sir.
Okay. Okay. Today I will share all the things. Last date, what I said. Last date. Last date video. If you remember me, I will correct. I think 24th.
That is
Huh?
24th and 25th we got.
25th also you got, huh? Okay.
I think yes.
Only
till,
yesterday's is
10th
pending,
will
sir.
be-
Okay,
Yesterday's
only
today.
yesterday pending. Oh, okay, okay. Yeah, I will share. Thank you. Thank you all of you. So
So,
9:30 people get ready within 15 minutes.
Sir, okay, sir, but for 9:30 batch, we haven't received from 22nd, sir. The last recording was on 22nd.
Okay, okay. Just
Haven't received, sir.
connect with me in the after 15 minutes. Connect me and remind me. I will
Okay,
check.
sir.
Hmm?
Okay, sir.
Yeah,
Okay.
I will take a tea break and I will connect by 9. Now the time is 10:05.
10:05,
By
yes, sir.
10:25 I will connect.
Okay, sir. Okay, sir.
Yeah, thank you.
Sir, can you share the Python videos as well, sir?
Yes, sir. Yes, sir. Huh? After completion of
thank you.
I have one more session. After that, I will definitely.
Sure, thank you.
Yes, sir. Thank you. Sir, who needs Python sessions? Just ping me, sir. To do the more practice of the PySpark, you need Python knowledge. If you want Python, just share. Just put a request. I will share you Python videos. Okay. All of you, thank you, sir.